let me kind of introduce you a little bit more so our attendees can have that proper introduction to you. But Manfred really, like I like to say he's kind of synonymous with Angular. He's just really made a great name and reputation for himself within the Angular community in particular, but his skills go beyond that as well. He's just an exceptional developer in general. He is behind AngularArchitects.io, where he and his team are expert consultants and trainers. They do regular like training events, both in Austrian, but they also offer English as well. So, take your pick. But then he is an Angular GDE. He regularly consults with the Angular team on updates and new features coming out, just all sorts of things with the Angular framework itself. He is a writer for O'Reilly and more. And yeah, just a very popular, sought after speaker. So we're really lucky and grateful to have him with us today. But Manfred, with your question, I've been asking our other speakers a bit of an icebreaker question with yours. We're going to tweak it a little bit. And so I'm curious what you think, what does quality in software engineering mean to you?
Yeah. So I think in former days, people had the impression that we can just implement some code and afterwards we can test some quality into the code. But I think meanwhile, we all know this does not work, that we can test quality into code. So I think quality needs to address all the stages, all the tasks around software engineering and development. It starts with requirements and it goes on with the architecture and it goes on with the implementation. A lot of stuff we just heard from Mikey. And then, of course, testing is still something, but normally you do it in parallel to the implementation. And yeah, so it's a lot of stuff you need to make sure of. And it's not just about testing at the end.
Right. Yeah. Being an all-around developer. I love that. Okay, well, I will shut up and let you do your presentation, and then we'll have about a 5-minute Q&A with you as well at the end.
Sounds good. So thanks for having me again. And yeah, this is about what I'm calling, and not only me is calling it that way, vertical architectures. And I want to start with a picture, this picture here. So what do you see on this picture? You see two neighbors and you see one neighbor smile. So it looks like they like each other. Perhaps they are even good neighbors. They have a good relationship. But we see one thing in addition, which is fences. We see fences between them. And this brings me to a very common proverb. I guess you know it. It's good fences make good neighbors, isn't it? And this is more or less what vertical architectures are about. If you go with vertical architectures, then you subdivide your whole solution into so-called verticals, into areas that don't need to know much about each other. There are fences in between. Each vertical has some co-located features, and you really try to minimize the dependencies. That's why I'm saying there are fences in between. We cannot directly grab over and use something from over there. And another aspect of verticals is we can start assigning different teams to different verticals. I deal a lot with large scale projects where we have several teams. And in this case, it's always good to dedicate one vertical to one team so that they can really focus on this very aspect of the overarching solution. And this, by the way, also correlates with the so-called Conway's law. Conway, several decades ago already, claimed that your architecture, your software architecture, always mirrors your team structure. And if you structure your teams accordingly, you can use this to get the software architecture you want to have. So both is correlating with each other. And another aspect of all of this is when we go with verticals, having nice fences in between, we can something change here without breaking something else there. I think this is a situation we all have seen so far, a quite ugly situation, and having fences can just stop this cascade of changes. However, while this sounds quite simple at first glance, the idea of verticals brings up several questions. For instance, there is the question, how large should a vertical be? Or another question is how to find good verticals or how to implement them. And my goal is to provide some answers to those questions today. Before we start, let me quickly introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. I'm quite connected to the Angular community. I live in Austria. I do a lot of stuff in Germany, and I'm always happy if I can work together with people around the globe. We have some customers in the US and some customers in other parts of Europe, and it's always fun to work together with those people. Okay, so let's get started with the first question. How large should a vertical be? And funnily, this question cannot definitely be answered, but there are some forces that influence the desirable size of your verticals. For instance, the minimum size is influenced by correlating features you have, because somehow you want to place correlating features, features that need to know something from each other into the same vertical, because the verticals should be decoupled from each other. And so it would be counterproductive if you had several features that need to know about each other in different verticals. So this for sure influences the minimum size. The maximum size, however, is influenced by the capacity of a team, because it's desirable to assign a vertical to one team so that they can concentrate on one thing. And that's why a vertical should not be larger compared to what a team can achieve. So those are two forces that help us to find good sizes. Another question is, as mentioned before, how to find good verticals. And this is really a hard topic. And that's why I've prepared a lot of slides here and even two completely different perspectives. The first perspective is about 20 years old. It's from domain-driven design. Domain-driven design was defined more or less with this book more or less 20 years ago. And this book is still a bestseller. This is quite nice because I think there are not that many books about software development that are still a bestseller after all those years. But this book is. There is a vivid community around this topic. There are several conferences. A lot of further books have been written on this topic, and a lot of additional enhancing concepts have been developed during the years. And basically, domain-driven design tells you to align your software with your business domains, with the real world out there, which is also the promise of object-oriented programming, where we also want that to mirror the real world inside of our software. So if we look at domain-driven design from a high-level perspective, we see two traditional disciplines. The first discipline I have here is less known. It's strategic design. It's mostly about decomposing a system and about defining how those different parts can interact with each other. And I think already this description shows this fits quite nicely to verticals. And the second discipline is about tactical design, which is about design patterns and practices. A lot of those patterns and practices are meanwhile common knowledge. Of course, domain-driven design gives them a special spin, but more or less they are common knowledge. And I also think this part of domain-driven design is better known. However, today, I really want to focus on strategic design because it's more important and lesser known. And so let's go on with this. The idea of strategic design is to not implement a big system that can do everything. Instead of this, we decompose it to several subdomains. Instead of having a flight management system, we could have a booking system, a check-in system, luggage, and boarding. In domain-driven design, you call those parts subdomains. They don't need to be fully isolated systems. They can also be a part of your overarching system, but they should know as little as possible from each other, because the goal is to change something here without breaking something there. So usually they are loosely coupled. They don't know that much about each other. However, to identify those subdomains, you need to look at your business processes. And this is something you might not expect from a software architect, because a lot of people think software architecture is mainly about technical things. But the truth is, you really also need to understand your business and your business processes. So you look at your overarching business process, and then you try to identify parts where you can cut everything into pieces. For instance, you could look at the vocabulary. You could say, well, here and there we are using the term luggage, and it's not only the same term, it's also the same term with the same semantics, which nicely correlates what Michael told you before. We have the same semantics here, and so we might have found a candidate for a business domain. Check-in luggage, pick-up luggage could be one business domain. At least it's one candidate. Then there is another concept that has been described only some years ago. It's about pivotal events. A pivotal event is something where you are relieved. So let's say you need to book a flight and you are really stressed out because we all know flight prices are going up all the times. And so you are really stressed out. You want to get this flight. But once you have booked this flight, you are relieved. You can check this task on your task list, and then it's going on a different place and or with different people and or at a different moment in time. It goes on when we arrive on the airport. And then one more time, we are stressed out. We have to check in. And once we are checked in and once we are also in the security area, I think you know this feeling. We are really relieved. Nothing can happen anymore. Check on the task list and that's it. And then you need to go into the plane and then one more time you are relieved. So if you look out for such events, then you also have good candidates for a position where you can slice the overarching process into pieces. Someone once said such a pivotal event is more or less like a scene cut. So if your life was an action movie, you had a scene cut here, and then it goes on 2 weeks after at the airport. Well, my life is less of an action movie. It's more of one of those French movies, you know them, with a lot of dialogues, but nevertheless, there are some scene cuts in there. A third heuristic to identify parts where you can cut everything into pieces is the structure of your company in terms of divisions, but also in terms of roles. So you could look out for people working with this or that part or mainly influencing this or that part of the business process. And all of those things gives you some heuristics for finding good cuts so that you can slice everything into subdomains, which will be your verticals in this very case. Let me also show you a funny thing. Of course, this example is a bit made up for this, but if you go with pivotal events, then you might say, well, this here is a domain. If you go with, let's say, vocabulary, then you could say, well, this here is a domain. We are using the term luggage with the same semantics. And if you go with the roles you have in your company, then you might say, well, the check-in agent and the boarding agent is literally the same person. That's why you always have to be nice to the check-in agent when checking in. And so this would be a candidate for your domain. And as you see, it's overlapping, isn't it? And this might be frustrating because now we see we have some heuristics, they are in handy, but they can point into different directions. And so at the end of the day, we have to decide by ourselves which of those heuristics works now for this very case best. Which works best to have some decoupled subdomains. Even though this is difficult, I have two things for you that might be relieving. One thing is there is never a perfect domain cut because you always have to go with trade-offs. You always have to go with compromises. And the second thing is you are not alone. You can do this whole game together with other experts. And this is where event storming comes in. So the person you see here is the person who invented the idea of event storming. It's a nice concept where you bring together business experts and software development experts. You more or less lock them up in a room and you make sure they have a big white wall and a lot of post-its. And then with those post-its, they start to model the whole process. Orange post-its, for instance, stand for events that happens on your main process. An event could be ticket booked, or an event could be checked in or boarded, or got luggage back, something like this. And there are other colors, other post-its with different colors that add some additional information. But the most important aspect here is that you are defining the events that in turn define the whole business process. And the nice thing about this is that you do this together with domain experts. And so if you have the impression that one of the post-its are not located on the right place, then you start a discussion. And this discussion helps us to bring all our knowledge together, the knowledge from the experts, the knowledge from the developers. And so we build a common knowledge and a common joint understanding, which is quite nice. Usually after 2 or 3 days, you have a good overview of everything and you know where you can slice the process into pieces. Talking about slicing it into pieces, in a second round, you might come up with some vertical boundaries. You just draw a vertical boundary. And if you have the impression that someone else has drawn a wrong boundary, one more time, you start a discussion. And so you also bring your knowledge together to find out about where to slice everything into subdomains. So for me, this is really a nice approach and perhaps even a missing link because it links several important disciplines. It links agility, it links requirements, and it links all of this to architecture. So it could be more or less a cornerstone. When talking about domain-driven design, we should also talk about the fact that we really try hard to model each domain separately. So here we see 2 domains, booking and boarding, and we have flight twice. We have flight twice, and this is not necessarily a redundancy because, and one more time, I'm referencing to Michael, one more time, we might have different semantics. The semantics from a booking perspective might be completely different to the semantics of a boarding perspective. When it comes to booking, we need a lot of information about the flight because we want to sell a ticket. If it comes to boarding, the flight is perhaps just a little tiny amount of data so that we know which of the planes we are referring to. So it's a different thing, and that's why we really try to model it differently. And this makes sure we have a model that fits our brain, and it also makes sure that we don't have too much intermingling, too much coupling. Just a little tiny metaphor. Think about a map. And just imagine this map not only has roads in it, but also mountains and valleys and your vegetation and your air roads for the planes and the railway connections and the water pipes and the sewers. This would be a map that would be useless because we have too much information in there. And to prevent this, it's really a goal of domain-driven design to model each and every domain separately. This reduces the cognitive load and makes sure we have a model that fits this area quite well, but not everything. So it's about cognitive load and decoupling. So perhaps two fancy terms that are important here. One term is the term of the bounded context. The bounded context is the boundary within which the model makes sense. Outside of this boundary, the model does not make any sense because we have different semantics outside of this boundary. Flight has a different meaning on the other side of this slide. And in there, we have the ubiquitous language, which is the general language everyone is speaking, domain experts, but also we developers. And we really try to mirror the domain with those language in our source code. It's also about semantics, and it's also about making sure we mean the same when we say the same. This was one perspective, domain-driven design, but I also want to show you a completely different perspective. And as you will see in some minutes, funnily, those two different perspectives are just two sides of the same coin. So at the end of the day, and this is really funny, they really nicely correlate with each other. The second perspective I've brought with me is called Team Topologies. It has been described in this book here from 2019. And I also guess this is one of the books that will still be vital, important in 20 years. So I see it in the same area as the domain-driven design book. And basically, it describes 4 fundamental team topologies and 3 modes of interaction. So how those different teams can interact with each other. And just to put it in a nutshell, I think this graphic here, this diagram I took out of the book, sums up everything quite nicely. So what we see here are, for instance, the 4 team topologies. We have a platform team, for instance, that is implementing infrastructure code for you so that other teams can quickly build something that gives us business value. Your design system or the library implementing your design system is in this area. But also your house internal framework, perhaps a framework helping you with Micro Frontends or other stuff is built there. The most important teams, however, are the stream-aligned teams. They are aligned with a stream of value. So it's all about producing business value. And funnily, those stream-aligned teams normally take care of a vertical of their own. A vertical that provides value for a given area of your business. In our case, it might be booking or boarding or luggage, something like this. And the goal of all of this is to make sure we can provide value without any interruptions. Or to put it in another way, we want to accelerate the flow, which also can be measured by the average time a ticket takes to go through the whole process. So it's all about providing business value as fast as possible. There are some additional teams, like teams for complicated subsystems, like perhaps a car configurator with 3D and so on, might be quite complicated. And so we are assigning it to a team of its own. and then the team for the web shop is incorporating this piece of code. And here we have an enabling team, which helps the stream-aligned team to learn everything they need to provide business value without interruptions. For instance, to learn about CI/CD. CI/CD is indeed not the task of the enabling team, it's the task of the stream-aligned team. However, we know we not always have all the knowledge in all the teams. And so we have enabling teams that work sometimes with them and teach them how to do it by themselves so that they can adopt their CI/CD process without any other interruptions. Or another enabling team might be a performance team or database specialists that know how to deal with your Oracle database or something like this. So I think, to put it in a nutshell, stream-aligned teams should work without any interruption, and usually they concentrate on one vertical. And there is another aspect in there. It's about cognitive load, which means that, of course, we are limited with what fits our brain. But not only we as individuals, only a team as a whole is limited to what fits their brain. And so it would be nice to have a respective cognitive load and not a cognitive overload, because if a stream-aligned team has too many responsibilities, then it's really hard for them to process everything, and so they cannot provide business value without any interruptions. Funnily, there is a nice podcast about this very topic. Joe Eames talked about this very topic in 2 parts of the Dev Life podcast, and he is using a nice metaphor. He is talking about your brain capacity that can be compared to the RAM of your machine. Your RAM is limited, and switching the RAM, swapping data or loading something from hard disk is always an overhead. So we should make sure that we don't have more tasks to accomplish that fits our RAM. And one more time, this perfectly correlates with the idea of verticals, where each and every team has one vertical they can grow an expert into. A vertical with a topic they can become an expert for. This is also really funny because this perfectly fits to domain-driven design. Team Topologies defines so-called fracture lines that allow us to cut our whole process into pieces for different teams. And what they are saying is the most important fracture line is your business domain. And this is where this book references to the original book about domain-driven design. So they say, first and foremost, we should identify business domains in our code and model those business domains separately and assign different teams to different business domains. However, and this is also quite enlightening, they also come up with alternatives to business domains. They say most of the times this fits, but sometimes you might make an exception because there are further fracture lines like regulatory compliance or change cadence, team location, risk, performance isolation, technology, and user personas. So let me just give you some examples. For instance, if we look to those here, regulatory compliances and change cadence, one of our customers is doing payroll accounting. And you know, payroll accounting is a very difficult topic because there are a lot of laws, and those laws those laws change on a regular basis. Each and every year you have adopted laws, and your software need to know about all of them, because sometimes you need to recalculate something from the last year or the year before. And so all the different laws and rules from all the years need to be baked into your system. That means we have a huge amount of change, and we are a victim of regulatory compliances. And so what they decided is they defined a subteam for this complicated part that is calculating the taxes for the loans and so on. And this subsystem is used by other stream-aligned teams that make sure that you can nicely define which employee gets which amount of money. But this is one example. Another example is, of course, team location. If you have a team on the East Coast and another team on the West Coast, for sure, it makes sense that the East Coast team is responsible for one vertical and the West Coast team is responsible for another vertical. Or if we think about user personas, if we think about an e-procurement system where sometimes an employee is requesting a new wrapper and the manager has to say, no, you already got a wrapper last week. And the vendor is then shipping the wrappers when the manager finally approves it, then it might be a good idea to subdivide the application according to those three roles and to have different verticals for them, especially if those three roles have a completely different UI and a completely different part of the overarching process. So the big question is now how to implement verticals. And for this, we have several options. We can just implement each vertical in a folder. We can implement each vertical in a library. We can implement each vertical with an application of its own. The later one is what leads to micro frontends, isn't it? One application per vertical, one application per business domain. And sometimes people say, well, it's just about folders, it's just about libraries. So what's all the emotion about verticals? Well, the important thing is thinking about verticals happens before. The folder structure is just the result of this, but the real hard part is to defining the verticals. So it happens before, even before we start writing code. So here I have architecture I use a lot in our customer projects. We subdivide our application into verticals that mirror business domains. And we have this shared vertical. And then we fill those verticals with libraries or folders that are categorized. This categorization is taken from the NX team that have published about this already several years ago. We have feature modules or libraries with smart components, UI libraries with dump components, data libraries for data access, and utility libraries for general purpose utility stuff. And this brings a lot of order into the system, but it also allows us to introduce some rules, like we can only navigate top down. One more time, this prevents that everything is intermingled with each other. And another rule, and this is a more important one in terms of verticals, is this here. One vertical is only allowed to talk with itself and with shared. So booking can talk to booking and to shared. Boarding can talk to boarding and to shared, but booking and boarding cannot talk directly to each other because we want to have loosely coupled connections here, or decouple it in the best case. So for implementing something like this, I like to go with NX. Perhaps you know NX, it comes with a lot of features for stuff like this. We can have libraries for motherialization. That means each and every cell in our matrix, each and every cell here becomes a library of its own, and then we can define which library is allowed to access which further libraries. We have incremental CI/CD that speeds up everything trandamously. We have a build cache, and we have builds that work in parallel in the cloud. So all of this is about build performance. Some people say, well, we don't want to have a library for all those cells here. And that's why a colleague of mine, Rainer, implemented the so-called sheriff, which is doing the same. It's also highly inspired by NX, but it defines those boundaries on a per folder basis. So it tells us, well, code in this folder is not allowed to access code in that folder. And one more time, this assures that everything is decoupled. So if we look at the slide from before, we can still combine this with NX, but for the modularization boundaries, we just go with folders, and all the other goodness comes from NX. So let me show you a little tiny example about all of this. It's a tiny example about flights, of course. We have a flights app. And in there, we have a domains folder. And there we have all our subdomains with their own bounded contexts. Check-in and luggage and ticketing. And here we have this special shared vertically. And if we go into ticketing, we see here our layers. We have one folder that is associated with the data layer and 2 folders that are associated with the feature layer. And if we look into shared, we have 1 folder that is associated with the UI layer and several folders associated with utility. So if we go back to the slide, this really fits to this layering: feature, UI, data, utility, feature, UI, data, utility. So this defines how we can navigate top-down. But the more important aspect is there is not only a rule for navigating top-down, there's also a rule about which other domains we are allowed to access. And usually we don't allow code to access other domains. So if I try to access from within my ticketing domain here you see ticketing, my luggage domain, you see that my colleague Rainer is coming and he's hitting me on my fingers. He's always hitting me on my fingers, but it's for the better because I'm trying to access stuff I'm not allowed to access. If you look here at this error message, it tells me, hey, Manfred, you are in ticketing feature, so vertical domain ticketing layer feature, and you are not allowed, you don't have any clearance to grab over to luggage. It's forbidden. It's more than forbidden. It's verboten. Someone told me that the German term emphasizes forbidden if you just say verboten. And the good thing here is that this also works with the linter. So if I call ng-lint, I should get exactly the same error message. And that means we can check for those boundaries when source code is checked in. Let's do ng-lint. And how is it called? Flights. It's still an NX workspace. That means we can check automatically within our build process if we align with those rules. And if we don't align, we just forbid merging. We just don't allow that the source code lands in the main branch. So here you see this error. We have the issue that we don't have clearance for luggage because we are in ticketing and in feature. And this is really awesome because this means we don't get any broken windows anymore. Okay, cool. So let's go on. This was the demonstration. And yeah, let me come to a conclusion. So what did we see today? Well, we've seen that it's all about decoupled verticals. They allow you to grow over time. They allow you to change something here without breaking something there. They allow you to have a bunch of code that fits the brain of your teams. It's also about business domains. So usually we try to mirror the real world out there, your business domain, you know, but they are saying the real world is where the pizza boy comes from. We try to mirror it. And also our team structure is also mirrored in the software architecture. So by defining respective teams, you also define your software architecture. It's all about reducing the cognitive load, because otherwise we need to swap time and again, which is reducing our efficiency. And it's all about the flow and the value stream. We want to make sure our teams can work without any interruption and provide business value as fast as possible. And there is one last thing I really want you to remember, namely, good fences make good neighbors. So thanks for having me. I have already uploaded this whole material to my blog. You find it here on the start page, and follow me on X, Twitter to stay in contact.